Welcome to the podcast. We've got data news about civil engineer focused on pavements.
Hi everybody, my name is Alisson.
Hi, I'm Emily.
Hey, and I'm Emilia. And today we're going to talk about traffic loading and volume. So let's get started.
As you know, traffic is one of the most important factors in pavement design. This should be included in the loading magnitude and configuration and also the number of load repetitions.
Yes, but we have to focus in the three different procedures for considering vehicular and traffic effects in pavement design. These are fixed traffic, fixed vehicle, and variable traffic and vehicle. Well, Emilia, you know more about it. Can you explain us, please?
Yes, Sammy, for sure. The first one is fixed traffic. So the thickness of pavement is governed by a single wheel load, and the number of load repetitions is not considered as a variable. If the pavement is subjected to multiple wheels, they must be converted to an equivalent single wheel load, ESWL, so that the design method based on a single wheel can be applied. An important fact is that the method is applied in highway pavements with heavy wheel loads but light traffic volume, like airports pavements.
Although, nowadays this method is not used more. In other matters, the fixed vehicle procedure manages that the thickness of pavement is governed by the number of repetitions of a standard vehicle or axle load. Usually, the 18 kip single X load, if the X load is not 18 kip or consists of tandem or tandem axles, it must be converted to an 18 single X load by an equivalent X load factor, EALF.
Okay, girls. In brief, the load equivalency concept could be applied in the design process separately. In that way, there are two types of load equivalency. The equivalent single wheel load, ESWL, and the equivalent axle load factor, EALs. The first type is based on the fixed traffic procedure of converting the most critical wheel loads, usually in multiple wheels, into an equivalent single wheel load and using it for design purpose. The second one is based on the fixed vehicle procedure of converting the number of repetitions of a given axle load, either single, tandem, or tridem, into an equivalent number of repetitions of a 18 kip single axle load.
The last procedure is for variable traffic and vehicles. Both must be considered individually, so there is no need to assign an equivalent factor for each axle load. It sounds like Axl Rose, the musician. Anyway, the loads can be divided into a number of groups, and stresses, strains, and deflections under each loaded group can be determined separately and used for design purposes.
In addition, we have some criteria that have been used for determining the equivalent single wheel load for a two-layer system. These criteria are equal vertical stress, equal vertical deflection, equal tensile strain, based on equal contact pressure and based on equivalent contact radius.
Furthermore, the equivalent axle load EALF defines the damage per pass to a pavement by the axle in question relative to the damage per pass of the standard axle load, usually the 18 kip single axle load. The design is based on a total number of passes of the standard axle load during the design period, defined as the equivalent single axle load. ESAL result.
That's right. Also, as you're concerned, the EALF depends on the type of pavements. Thickness are structural capacity and the terminal conditions, where the pavement is considered failed. Besides that, one of the most widely used methods is based on the empirical equations developed from the A-show road test.
In the flexible pavement, under heavy axle loads with an equivalent factor much greater than unity, the EALF increases as the terminal serviceability, which indicates the pavement conditions to be considered as a failure decreases. This is as expected because heavy axle loads are more destructive to poor and weaker pavements than to good and stronger ones.
Yes, gears, but it's important to know that in the rigid pavements, the EALF have another procedure that consists in an equivalent factor. This is proposed by the normative ASHTO and have some equations for determining this. You can find them in the chapter 6 of the book Pavement Analysis and Design by Yang Wang. I have it. If you want, you can tell me.
Yes, of course. Thank you. I will follow your recommendation. I think it's time to talk about traffic. How is it in your city, Alice?
What can I say about it? It's a mess.
Why? How does it affect in your daily routine?
Well, when the COVID doesn't exist, I have a lot of problems when I was going to university. But nowadays, with all the restrictions, especially on Fridays, all the people hang out on the streets to provide food for the weekend, and the traffic it's so intolerable.
Yeah, I agree with you. I don't like it either.
I can imagine. By the way, talking about traffic, I would like to commend you the importance of predict the number of repetitions of each axle load group during the design on a highway pavement. The traffic to be used in design is not the average traffic during the first year, but the average during the design period. Also, three different methods based on the compound rate are presented to compute the traffic growth factor. The use of average traffic at the beginning and at the end of the design period gives the highest growth factor, while the use of traffic at the middle design period results in the lowest growth factor. Sorry for that.
Also, I know that the minimum traffic information required for a pavement design is the average daily truck traffic, ADTT, at the start of the design period. In addition to the initial traffic and the growth factor, the directional and lane distribution factors must also be considered, unless the traffic loading or volume is heavier in one direction than in the other due to some special reason. A directional distribution of a 0.5 is assumed. The lane distribution factor varies with the number of lanes at the ADT.
Not only the initial traffic and the growth factor, but also I think that the truck factor is necessary because the different classes of trucks individually affect the payment. A single truck factor can be applied to all trucks, or separate truck factors can be used for different classes of trucks. It should be considered if the growth factor for these are not the same.
Yep. In addition, to determine the growth factor, a simple way is to assume a yearly rate of traffic growth and use the average traffic at the beginning and at the end of the design period as the design traffic.
Emilia, don't forget some factors that might be considered, like attractor or divider traffic due to the improvement of existing pavement, normal traffic growth due to the increased number and usage of motor vehicles, and finally, development traffic due to change in land as used as a result of the new facility.
Girls, don't forget about the lane distribution factor. It is very important. For two lanes, highways, The lane in each direction is the design lane. So the lane distribution factor is 100%. And for multi-lane highways, the design lane is the outside lane.
What's more, there are some considerations that may help in pavement design. The first one is the passage of a set of tandem or tandem axles. Amy, do you have any idea of what does it mean?
Um, as I'm concerned, if the design is based on the equivalent 18 kip single axe load, the passage of a set of tandem or tandem axles should be counted as one repetition because the equivalent factor is based on one passage of the tandem or tandem axle loads. If the design is based on different load groups and the stress or strains under single tandem or tandem axle load are used for damage analysis. The damage caused by the passage of a set of tandem or tandem axles should be analyzed by another method.
Oh, wait. Emilia, a cat got your tongue?
Huh? Pardon me, I was listening to you. The required number of repetitions may range from 1 to 2 for tandem axles and from 1 to 3 for tandem axles, depending on the combined effect of pavement thickness and subgrade support. On the other hand, for flexible pavements, the passage of a set of tandem or tandem axles may be considered as one repetition for thicker pavements on a weak subgrade, but as 2 or 3 repetitions for thin pavements regardless on the subgrade support.
Yep. And also for rigid pavements with poor subgrade support, the passage of a set of tandem or tandem axles may be considered as one repetition, but the number of repetitions is increased as the subgrade support improves. However, it should be pointed out that general trends are based on the input data assumed.
I read that the best way to analyze the damage of complex interactions among all the design variables are using the software CANlayer or CANslabs instead of applying a fixed number to tandem or tandem axles.
Wait. What's CANlayer, CANslayer?
CANlayer. CANlayer is a very common payment software used for modeling and design payments in the USA.
Oh, you can never learn enough.
Once I used this software for a science project. That's why I know about it.
Experience is a matter of knowledge.
That's right, Amy. What else can you say about CANlayer?
I know that the damage analysis indicate that the passage of a set of tandem or tandem axles may be considered as one repetition in some cases, but as more than one repetition in other cases, depending on pavement thickness and subgrade support.
But the problem is so complex that it's best to analyze each load group, either tandem or tandem directly, instead of applying a fixed number of repetitions.
Oh, easier said than done.
Girls, I have a doubt. Whether the effect of traffic wonder or lateral load placement, it should be considered in the design of highway pavements or not.
Traffic wandering certainly has a great effect on pavement damage.
Of course. However, instead of reducing the number of load repetitions, the effect is incorporated in the failure criteria. In the PCA method of rigid pavements design, the wandering effect is considered in the fatigue analysis by reducing the edge stress in the erosion analysis by increasing the allowable number of load repetitions.
So that's it. Cool. I really like to talk about this with you.
Yes, I enjoyed it. It was an awesome conversation. I learned a lot with you.
I agree with you. Talking about payments was interesting. I hope we can have another meeting as soon as possible. See you.
Yes, please. See
See
you, girls.
you. Bye.
See you. Bye.